All right, today we're going to continue our discussion of sequences, and we are going to learn specifically about the explicit formula for an arithmetic and a geometric sequence. So first, let's review. An arithmetic sequence is a sequence where you add to find the next number of the sequence. It can be thought of as a linear function. Remember, linear just means it's going to make a straight line because it's adding or subtracting every time. And then also remember the formula for a linear function is y equals mx plus b. This is going to matter when we're going over how to find the explicit formula. So keep that in the back of your head as we do this. So let's review. A recursive formula is a formula that has two pieces. The first piece is where to start. And if you guys remember, this is sequence A, so we know it's going to be A1 equals, and so you come up here and we see, all right, what number am I going to start at? Well, my first number right there is 4, so we can say A1 is equal to 4. Then we need to go through and say how to move. How is my sequence changing from number to number? Well, coming back up here, we can see that this sequence is going plus 5, plus 5, plus 5 over and over again. So that means it's going to be an equals 5 plus an minus 1. And so what that's saying is you're adding 5 every time. The problem with the recursive formula is if I want to know the 100th number in a sequence, I have to know the 99 numbers before. So now I need to figure out a formula that tells me what any number is. And that is what we call the explicit formula. The explicit formula is based off of y equals mx plus b. And remember, m is slope, and b is the y-intercept, or where you begin. So we're going to use those ideas, and we're going to find the explicit formula. Instead of a y, we're going to use an equals. And so now we got to figure out what m is and what b is. So m is slope, it's movement. And so if you remember, my sequence was moving by plus 5. And so I'm going to start with a 5. Then b is the y-intercept, or where you start. And so my sequence starts at 4. Now, what am I going to put with the 5? I'm not going to put x. It's going to be based off of n, just like I have an n right there. But an important fact is to know that that's 1. 4 is the first, 9 is the second, 14 is third. Well, the y-intercept is normally when something is 0. Well, we can't really worry about when it's 0. So what we do is we're going to put an n, but to make sure that we don't add 5 too many times, we're going to do n minus 1. So that's what your explicit formula is going to be. An equals 5 parentheses n minus 1, close parentheses, plus 4. M is 5, b is 4, and x is just n minus 1. It's all the same pieces, just shown in a different way. So let's go and talk about a geometric sequence. So a geometric sequence is much like an arithmetic. If we remember, if we can get there, a geometric sequence is a sequence where you multiply to find the next number. It can be thought of as an exponential function, and it's important to remember that the formula for exponential is y equals a times b to the x. So now we go through the process. My formula has the two pieces, where to start, And so in this one, we're going to do where to start in blue again. So we would say B1 is equal to that first number, so 7. And then we also need to know how to move. How is my sequence changing? And so for that, we look at our sequence and we see, oh, okay, so right there is times 2, and I'm just multiplying by 2 over and over again. So then it's going to be Bn is equal to 2 times Bn minus 1. Then we have our explicit. Once again, our explicit is based off of the formula, but this time it's going to be y equals a times b to the x, where a is your y-intercept, and b is what you multiply by. All right, just like what we've been doing. So it's what you multiply by. All right, so now we're going to write our formula. So we know it's going to be an instead of y equals my first number, which my first number was 7. So, and then times, well, what I'm multiplying by. So times 2. And x is not going to be x anymore. It's going to be the same as this. So it's going to be n and then minus 1 because we already start with the first number. Okay, once again, 7, it's where you started. 2 is what you're multiplying by. And n minus 1 because 7 is the first number, 14 is the second. And we want to know how many times we multiply by 2. All right, so now we're going to do some practice problems. Make sure that we can do this. So let's just go through these real quick. The recursive formula. Well, a1 equals 10 because that's our first number. An equals, well, each time it looks like I'm subtracting 3. So it's going to be subtract 3 plus an minus 1, right? Recursive formula, 2 parts. Now the explicit. Explicit is 1 part, so it's an equals, well, I'm changing by negative 3. My x would go there, but we're going to put an n minus 1, then plus 10. Okay, so that's it. I know that this can seem a little crazy, but let's just keep going and see if we start seeing the patterns. So for this one, a1 is equal to 81. And then an, this one's trickier. I'm dividing by 3, dividing by 3, dividing by 3. But if we remember, I don't really care what I'm dividing by. I want to know what I'm multiplying by. And so looking at that, I am multiplying by 1/3. So an is going to equal 1/3 an minus 1. The explicit formula, an equals, well, I start with 81 times 1/3. And then normally it's an x, but because it's a sequence, we start with 1. We do n, take away 1. All right, we got 2 more. So an equals 3 parentheses n minus 1 plus 7. Well, we know 7's my first number, so my sequence is going to be 7. Then over here we can see I am just adding 3. I'm adding 3. So that means my sequence is going to be 7, 10, 13, and finally 16, comma, dot, 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 because it keeps going. Then my recursive formula is going to be a1 equals 7, because that's where I started, and an equals 3 plus an minus 1. All right, the last one, a sub n equals 2 times 3 to the n minus 1. First number is 2, so I'm going to come over here and write it 2. Times by 3, so 2 times 3 is 6. Times by 3 is 18. Times by 3 is 54. Then the recursive formula will be a1 equals, and the first number is 2. And then I'm moving by doing 3 times an minus 1. So that's the explicit formula. Rewatch the video if you got stuck on any parts or if you're still a little unsure. And then let me know if you guys have any questions.